We're going to look at composition of hydrates, and here's some topics it relates to in chapter 10 in this book, but chemistry overall. Percent composition, mole ratios, and using lab measurements to learn something about a substance. Some vocab, hydrate, which is what we're going to be looking at. I'm going to use this many times today. An anhydrous salt. So anhydrous means without water. And then here's an example of a problem that you'll need to be able to do at the end. You should be able to do that. So there's some lab data. This is something that you could collect yourself if you had the equipment and the materials. But so a couple of things. We've got I've got this compound we're dealing with first, which is copper II Sulfate pentahydrate. And if you know the formula, you can make predictions. So if you knew the formula, then you could walk into lab and you would know, okay, if I heat this thing, I know how much water can come out, and you can, make a prediction. So here's one hydrate, right? This is copper II Sulfate pentahydrate, right? So we know the formula. This is a mole ratio, by the way. When you see this 5 here, there are 5 moles of water for every 1 mole of copper II Sulfate. All right, so we get the molar mass, and then molar mass is 249.71 grams. Actually, it depends on the molar masses you use. You might get a little different number based on rounding. But here's the question. Okay, so that's getting molar mass. That should be okay. I guess I should point out for the H2O, I recommend leaving that together. Calculating molar mass, a lot you really are thinking atom by atom, but with a hydrate, water's a small molecule. Leave it together, leave it as the 18.02, and get your 90 grams of water per 249 grams or so of this hydrate. Right? So this is a salt hydrate or a hydrate, and we can calculate. You can calculate the mass that is water. The mass that is water, by the way, is the mass that would be removed if we heat this enough, and we heat all of the water out. So one way I noticed students, they like to find a percent composition. Right? So if we want the percent composition, it's the part divided by the whole, and the part here is 90.1 grams of water. The whole thing, and this is just for molar mass, the whole thing is 249.71 grams of this whole formula times 100. We get about 36%, 36.08% water for this hydrate. Right? Knowing that, you can say, okay, well, I know it's 36% water, so if I know the mass that I start with, and I heat it, and I heat all that water out, that means the mass has to go down by 36%. That's the idea. So I know a lot of students did like to do it this way. We've got 10.00 grams sample of this copper II Sulfate pentahydrate, and if we multiply that 10 gram sample, by the way, this 10 gram, I just picked a number, right? You could weigh out a number, you could pick a 10 gram sample. If I multiply it by 0.3608, right? Not the whole percentage, but the decimal form, I get 3.608 grams of water. So a 10 gram sample has this much water in it. So if I heat this sample, if I took that 10 gram sample and heat it, the water is going to come off, and that water should weigh this amount. And then if we subtract, we can figure out the mass of anhydrous salt we expect. All right, so that's one way. I kind of don't like that we don't have a unit here, so I really prefer just thinking about this in a unit analysis terms. It's the same thing, same percent, really the same as percentage composition, but it's 10 grams of copper sulfate pentahydrate. Notice, I'm just writing, for every 249.71 grams of the whole formula, copper II Sulfate pentahydrate, yeah, you can see that, there are 90.1 grams of water. So you're just multiplying by that 0.3608, but it just looks nice, right? These units would cancel out, right? And you're left with grams of water. It just looks nice. All right, so either one is fine. All right, now I'll show you what it looks like, because in the lab, all right, so got some copper II Sulfate pentahydrate. Here we go. You can see the formula weight slightly varies from mine based on rounding. All right, so we do need to take the mass of our evaporating dish first. So I've got my balance. It's zeroed, and get 42.06. All right. Now I'm going to put in a little bit of $49.59. Okay, so 49.59. Notice I have the grams up here in parentheses so that I don't need to keep writing grams all the way down, mass in grams. So this, let's see, can you see that? Yeah, it's nice and blue, right? Looks like there's water in it. And I've got a ring stand here. I'll show you this setup in a second. All right, so I'm going to heat this. The next measurement we want is the evaporating dish plus the anhydrous salt. So what you should be able to do, even now as this video is going on, is you should first of all be able to calculate what is the mass of this hydrate that I'm using, and then go ahead and using this, it's the same, it's got 36.08% water. What is the mass that you expect to leave? So how much water is in this sample and how much water is going to be evaporated when I heat it? And then when I put it back on the balance, what should it weigh? So that's what you should try and figure out in the meantime. I'm going to get started. See the flame? Yeah, you can see the flame there. All right. Come on. You can see the flame's a little high. You can see a nice blue color. So 7.5 grams, just about. So what, 2.5 grams less. 2.6. I know I should probably just cut the tape. You can fast forward through this, maybe go back and forth, see the color change, color come out of it. 10 minutes. Nobody's going to watch this. It's 10 minutes. You get the idea, right? You can see the blue fading away. We want to make sure that that blue color is gone. Really, we want to heat this to a constant mass. We want to heat it and then weigh it and then heat it and then weigh it and make sure that each time we weigh it, the mass is staying the same. However, I'm probably just not going to do that. This is going to be, once that blue color is gone, this is going to give us results that are very good. All right, so I'm going to let this keep heating. This is what it's going to end up looking like. Right, we got this. So, all right, I'm going to All right, so I'm going to move this over just a little bit, holding the base. All right, let's do this calculation. See what you came up with. Still needs a little more time. All right, so we didn't start with 10 grams of sample, but we're doing the same thing, so I don't need to erase everything. We started with 49.59 minus 42.06. That's how much hydrate we had to begin with. So it's at 7.53. grams. So times 90.1 divided by 249. I got 2.72. That's 2.72 grams of H2O. So, since there's 2.72 grams of water in that sample that we were using, we would subtract that from the 49.59 and I expect 46.87. All right, it still has a little blue. I'm going to stop it and we'll pick up.